and welcome to the training video for the FireFighter CalcTool app for Android smartphones. Today you will hear about the innovative possibilities you will have with the app and how to use it.
Everybody knows how challenging it is to plan a longer hose line. This app helps us to do it very easily.
First, please go to the Settings menu and select Metric Units or US Units. This way, you can calculate with liters or gallons.
We would like to plan a longer hose line for our next fire drill. In our example, we will select an outlet pressure of 150 psi at the app.
Our next engine will be located at a distance of 9 hoses. We would like to transport 300 gallons per minute through these hoses, and we have a difference in height of 75 feet uphill. When it's downhill, just use the negative values. The length of each hose is 50 feet.
The app is flexible and allows you to select other values and different types of hoses.
When using metric units, the calculation is done for the stored hose coupling system, according to DIN 14811. When using US units, you can select the size in inches. The calculation is done according to the US NFPA hose friction loss standards. Now we just press Calculate and we get the result. The pressure at the end of our hose line is 36 psi.
This is the inlet pressure for the next pump, or the pressure at the nozzle, depending on the situation you have calculated for.
Let's try to do some friction loss calculations for your special objects in your area.
Hi, I'm Ryan and I'm a firefighter from Pennsylvania, and we've tested this great app at our fire department for calculating longer supply and attack lines. It's been extremely easy to use, very flexible, and it gives us some great new possibilities for firefighting. You guys have to check it out. I highly recommend it.
There are certainly historical buildings, industrial buildings or other buildings that deserve protection in your region. For most of these, there might be a required minimum discharge flow for hydrants.
The question is, what's the maximum discharge flow of the hydrants in your area? But how should we meter the flow of a hydrant? Here we have two possibilities.
The first one is the more exact one. Here you can use a big pipe with a pressure manometer on it. Or you have another facility to measure it like this. But it's important to have a large inner diameter. Now, connect a nozzle onto that. But do not use a fork nozzle, because we have to meter the inner diameter of the nozzle. In this case, we have 0.9 inches. The next step is to fully open the hydrant and the nozzle. Now we can meter the pressure at the opened nozzle. Please try to read the meter in 2 psi exact steps. Then close the nozzle slowly and measure the pressure at the closed nozzle. Finished!
Now we enter the values into the hydrant app. 0.9 inches, 66 psi at opened nozzle, 90 psi at closed nozzle. The desired minimum pressure at the hydrant is the pressure which you would like to have at the hydrant when you want to get the maximum discharge flow. This might be about 10 to 20 psi. All selected? Now let's hit Calculate. For that hydrant, we get a maximum discharge flow of 317 gallons per minute.
As you can see, metering and calculating the maximum hydrant discharge flow is really quite easy. Don't forget to take the measurements for your operational area so you know how much water you can discharge from your hydrants in case of fire.
I am working for a water supply company here in the UK, and we had to measure the maximum discharge flow of the hydrants in our area. With the Hydrants app, we saved a lot of money because we were able to do that ourselves. We gave all the data to our firefighters and they are very happy because they know exactly how much water they can discharge in case of a fire.
Wildland fires are increasing more and more. The only thing we can do as firefighters is to prepare with practice and training. The program Tanker Shuttle helps us to do that. Using Tanker Shuttle, we can calculate how much water can be transported to the wildland fire.
First, select the distance between water intake point and discharge point. Let's say we have 2.1 miles.
But what is that discharge point?
At this discharge point, you can use a mobile water tank or a fixed tanker. The tanker shuttles discharge the water to the fixed tanker. This tanker should have at least the same capacity as the largest tanker shuttle. From that point, water can be transported to the tech lines. The next step is to select the number of tankers and the capacity of each. We use 3 tankers with 500 gallons and one with 1000 gallons. You can adjust these values according to your situation. Let's press calculate and see the available flow for our wildland fire. We can use 131 gallons per minute. The help buttons are useful for any detail of the app.
With this calculation, we can do a rough planning of our tanker shuttles. If we need more water, we can increase the amounts of tanker shuttles and recalculate with the app. As you can see, the calculation is very easy. Try to practice doing it yourself the next time you're out in the field.
Hey, what's going on? My name is Justin, and recently an instructor at my FireFighter Academy showed us this cool FireFighter CalcTool app, and we were very all amazed by it. Some weeks ago we had actually a wildland fire, and I took my smartphone, I opened up the app, and I was actually able to calculate our tanker shuttles to get the fire out fast. And if it wasn't for this app, then maybe the fires wouldn't have been out for, another day or two. So it's awesome. We were using 5 tankers and had a distance of 2.5 miles to transport the water, and my chief was very, very stunned by just the easy calculation that I was able to do with the app. So thank you for that handy tool. I really, really appreciate it, and it's helped me put out some fires, and it's also helped me get a little raise for my boss.
Portable pumps are very versatile, but we also want to buy the biggest pump we can get. The question is it better to use a smaller or a larger portable pump?
Have you ever asked how much water can really be transported with a portable pump? No? Well, then you're in for quite a surprise.
For our calculation, we would like to use a portable pump with a maximum flow of 500 gallons per minute and a maximum pumping head of 75 feet. We would like to pump water through 2 hoses of 2.5 inches each and a difference in height of 10 feet uphill. Now, I would like you to guess the amount of water that can be transported. Is it 450, 350 or 250 gallons per minute? We can only transport 230 gallons per minute, so this is 54% less than the maximum flow.
To check that calculation, we have done measurements with an ultrasonic flow meter. The values match up.
So we should try to achieve following.
Reduce the number of hoses. use large diameter hoses. Try to avoid buckled hoses. Avoid also valves and instruments. Try to reduce difference in height. And try to position additional pumps as close as possible. As we have seen, it's also possible to use portable pumps to feed engines with water. Within the app, you may select the pressure at the end of the hose. If the water discharges at the hose, just select 0 psi. If the water flows to an additional pump, select the pump inlet pressure between 1 and 6 psi. You can reduce friction losses by using parallel hose lines. Then you can have a higher discharge flow.
So, try to do some calculations for your portable pumps and pre-planning for your possible operations.
I am convinced that you will find this innovative app useful for several calculations in your area, and you will be more prepared during drills and in case of fire.
If you have any questions or ideas for improvements, just drop us a line at this email address.
Special thanks to our sponsors: Techsport protecting you, Havle Hydrants, and the ultrasonic flow meter by Maiden. Have a lot of fun with this innovative app. The innovative firefighting calculation tool for your Android smartphones and tablets. Get it now!